Well, hello guys, it is me, The Real Brownie, and we're back again this week with another video. Today I'm going to tell you how to win 1 million. In order to win this 1 million that I'm specifically talking about, there are something I've got to tell you about first. There are 7 problems called mathematical problems called the Millennium Problems that were set in the year 2000, and whoever solved one of those would get a million. In 2003, one of the problems was solved by Grigory Perelman, and he solved the problem. He solved the Poincaré conjecture, but there are 6 other problems like P versus NP problem, Hodge conjecture, Riemann hypothesis, Yang-Mills existence and mass gap, Navier-Stokes existence and smoothness, and Birch and Schwitterdon-Dyer conjecture. And what has happened this last week is that a man called Michael Atiyah, who's 89 and has a Fields Medal and Abel Prize, which, if you don't know, there isn't a Nobel Prize for mathematics, so there is these other prizes, has come out and said that he has solved one of the Millennium Problems, specifically the Riemann's hypothesis, which I am going to talk about and explain from what I know, which won't be a very specific explanation from a mathematical point of view, but for my audience, so that you can briefly understand it, and I'll explain it quite easily so that everybody can, with a low level of mathematical knowledge, can understand it. So I'm just going to start off by explaining what is a complex number. So a complex number is, like, for example, Z equals X plus, so you've got this, which has got a real part, the real part of Z, and the imaginary part. Okay, so that is the basic thing. So if we get and draw a graph like this, which is not that straight, but it's quite having in this axis the real part like that, and here the imaginary part, we've got we've got this graph, okay, which here you have the numbers 1, well, 1.5, like 1, 2, whatever, 3, I don't know, well, just the numbers like that, and an imaginary number, this letter I represents -1, but like that, which doesn't really exist, but it's imaginary, and we use it here in the graph. Like, this is the imaginary part, the complex part. We put I, 2i, 3, whatever. So, and then here -1, -I, -2. Well, it doesn't really matter. But the thing is, first thing I'll tell you is that Riemann's equation, you've got this like Greek letter, but it doesn't really, it's not that relevant. You've got a Greek letter that is like a function, that is, and S is the number you can substitute, and it starts by going 1 divided by 1 to the power of S plus 1 divided by 2 to the S plus 1, like that. Okay, and it goes on to infinity, when you put a number here, it'll give you, it'll add up, but sometimes all this adding up to infinity will converge to one single number, which could be 0, and those are the numbers that that for the hypothesis Riemann is looking for, those S numbers that give you 0. But we know, well, the mathematicians know, and if you put, for example, -2, which here in this part is when it's a real number, it has 0 as an imaginary part, so this part would be 0. All these numbers along here. We know that, well, firstly we know that here there's no limit, and that all the numbers from here to there, so all this part here, all the numbers to there, the function is convergent, and all the numbers from here to there, so all the numbers in this part, divergent. But the thing is, you can get, I think it's, for example, in -2, if you substitute here with yes, you do get the adding to infinity a 0, and also -4, and so on. But those are non-trivial numbers that we know about. But in this line here, there are loads of numbers with a real part 1.5 and imaginary whatever, but that make the function, Riemann's function, go to 0. But the thing is, to get that 1 million and prove the hypothesis wrong, you would have to find a number in this green area or this green area which isn't in this line, that putting it in here, you would get a 0. So if you did that, you found one number, you'd get 1 million. But it's almost impossible. Well, they haven't found one yet. The other way to prove to get the million would be by proving that all the numbers that make non-trivial numbers that give you a 0 are in this line. We know there's trillions here, but there's no proof that they are all here. So you would have to mathematically prove that they are here. If you did that, you'd get that 1 million they are offering.